In the last class, I told you, no, I'll be taking some questions on angular momentum, conservation of angular momentum. Let me select them. Hmm. Repeat, take this question. Not come yet. This question is on conservation of angular momentum. Try this.
Hello.
Hello.
Yes, sir.
I have given this question. In the last class, I have told na I'll be giving you questions on conservation of angular momentum. This is the first one. Hmm. अच्छा, लास्ट क्लास में मैंने ये बता दिया था ना तुम लोगों को। दीवा ने डाउट पूछा था, दीवा आस्क्ड मी वन डाउट and she actually told us whenever a body is rotating about some axis with an angular velocity omega, its kinetic energy is given by half into I into omega square. You remember this, na?
Yes.
Hmm. Question understood, na? Everyone is able to understand the question?
Yes, sir.
Okay. You're able to apply the concept. You're having idea. If any one of you not getting the idea how to approach it or how to solve this question, then you can ask me. If you're getting idea, keep solving it.
Sir, 24 joules होगा.
हैं?
24.
हाँ, 24. Very good. Actually, see, this question is not that difficult. Two disks, I1 and I2, about their central axis and normal path of plane rotating with angular speed 10 and this means there are two disks. One disk is this, suppose. Other disk is this one, I2, omega 2. Rotating with angular speed this and this. They are brought into contact face to face with their axis of rotation. The loss in kinetic energy of system. Now first see, when they are brought face to face, they became like this. One is this, other is on this. Now, the first problem is you need to find out their combined angular velocity. So what we'll do? Conservation of momentum will hold because there is no net torque. The two disk system, friction on one disk will be equal and opposite to the friction on other disk. The net torque on this both system will be zero. So we can apply conservation of angular momentum. I1 omega 1 plus I2 omega 2 is equal to I1 plus I2 into omega naught. Omega naught I am taking the combined angular velocity. So it will be simply 4 into 10 plus 2 into 4 is equal to 4 plus 2, 6 into omega naught. 40 plus 8 is equal to 6 omega naught. 48 by 6 omega naught, you're getting 8 radian per second. Now they're asking loss in kinetic energy of the system. The initial kinetic energy was delta K that they are asking is equal to initial was half I1 omega 1 square plus half I2 omega 2 square. This is initial. Final will be half into I1 plus I2 combined moment of inertia into omega naught square. Just put the value and get the answer. You'll get I1 is given to you, omega 1 is given to you, omega 2 is given to you. Just put the values. You'll get 24 joule. Easy question to us. But see, it was asked in 2024. Okay for everyone now? Shall I move on to the second one? Eva, हो गया question?
सर मेरा 8 रेडियन पर सेकंड तक आ गया था फिर नहीं।
अच्छा, उसके बाद kinetic energy का डिफरेंस नहीं निकाल पाए.
यस सर।
पता तो था ना, अगर मैं नहीं करता तो तुम निकाल लेते ना खुद.
यस सर तो हो जाता।
तुम्ही ने तो बताया था. तुम्ही ने तो बताया था कल kinetic energy होता है फिर, है ना? What about everyone else? Haripriya, got the answer?
यस सर।
Shama, Shama, the question you gave, na?
Yes,
There in the first question there was a mistake.
oh, typing mistake.
Typing mistake. There was -2 initially. Actually, what happened na? I solved your second question very quickly. This first question I was trying to solve is not getting any option. And
Oh,
then I thought, what is the problem with the option D was also there. No option was correct. Then I thought, I think there is some mistake.
okay.
Then I moved back. Then I changed the minus. Then I got the answer. But actually, it was
Okay.
easy.
So,
Question was not difficult, but it was tricky.
yes, sir, it was like slightly tough.
Like, I try to solve this one. Everyone has solved. Kanishka आ गया ना तुम्हारा भी?
Yes, sir.
Okay. Now try solving this one. It's a projectile with angle. They're asking you to find out the angular momentum. Let me draw the diagram for you that you will understand it better. Then after this, we move on to the start. Interesting. It's translation plus rotation, and it has the actual application. You see, body mass 45 degrees. It is projected like this at an angle of 45 degree with the ground with the speed u. Angular momentum of body about the point of projection at the highest point. It will move like this. We all know this is a projectile motion. At the highest point, this is the highest point. They want the angular momentum about the point of projection, about O.
Sir,
Yes,
how to solve this question?
easy.
So can you
See,
solve it?
okay, let me see. At the highest point, they're asking.
So can I please just try for 1 more minute? I think I can do it.
Okay, do it, do it.
Sir, do you like train students for NSCP?
No, the lower classes, na? No,
No, sir, NSCP, sir, the Physics Olympiad.
Science Olympiad, na?
No, sir, Physics Olympiad.
Physics Olympiad, but for 11th and 12th class.
Yes, sir, for the NSCP.
Actually their preparation is not different. You have to solve the Olympiad questions. That's all. Syllabus is exactly same, na? Usually students who are preparing for JEE Advanced, na, they actually prepare for that exam also.
Oh, okay.
Nothing is different. Only the questions. The questions are of bit higher level. Means a good quality question which is asked, not of all level. The good quality question that is asked in the international level or the national level of Olympiad level question paper, na, that is equal to the advanced level. Good quality advanced level question is national. And
Okay.
so if you want to, if there is no need to prepare separately. If you want to give that examination, na, you do one thing. You buy one book, Olympiad book, in which the questions will be there, previous year questions.
Sir, but I only know some of the 11th portion. I'm not sure if 12th grade.
12th you do not know, na? You can take help. See, in the app, na, in the app, if you want to cover fast things you want to cover fast, then you can take the help of this app I have provided. There are some videos in the app you have not explored, I think. In those that app, you will find out class 12 videos also for some topics.
Okay, sir. Okay,
If you want, you can cover them and then try it.
okay. Thank you.
Sir, is x equal to 2?
Now x is equal to 8. How did you do it? Want to know?
Sir, at the like topmost point, the velocity will be u cos theta.
Correct.
So, and then I learned that in Mains we extend the line backwards and then we find the perpendicular distance. So that will be the height. It will be u square sine square theta by 2g.
Correct.
So I put that in the formula of I omega.
No need to do in the I omega, na. Now when you there two formulas I gave you, na. One is MVR sine theta, which is M, or the other way is M into V into R perpendicular. Okay, and the other is I omega. If you want to do by I omega, that's also not a problem.
So I later converted that ये formula use हुआ था.
MVR, na. Then also you
Yes.
should get the right answer. I don't know why you are getting wrong one.
So I think I should have done some calculations.
You did some calculation mistake. Your approach is exactly correct. Because u cos this MVR, because this is velocity, and about the point of projection, the radius will be h. If you want to do by that method, see the other one. If someone asks, sir, why you are doing velocity into perpendicular distance, I have given you this. And if someone is doing m into r, r cross v, this is r vector, this is theta, r sine theta will be h only. So MVR, this angular momentum L, will be m into v into r perpendicular, which is mass into u cos 45 into r perpendicular is this h. The maximum height, you know, that formula is u square sine square theta by 2g. So we'll put it m into u by root 2 into u square sine square 45 by 2g. So mu cube into by 4 root 2 into g. What they have given? Mu cube by see, root 2 is in the top, so we have to multiply root 2 at the top. So it will be root 2 mu cube by 8g. The answer is 8. Okay. Now you find out where was your mistake. Everyone else, did you understand? Where you got stuck? I'm asking Shyama, Haripriya, Radhika, Kanishka. Because you had no idea.
Sir, I did not take MVR sin theta.
Actually, I gave this question because of that only, the application of MBR sin theta. For that only I gave this. Because I omega you have already applied. Okay. Do you want me to give some more question on this? Or shall we move on to the next concept? Let's move on to the next concept. And later, actually you will be using it. You will be using it. Achha, let's start the next part. Next part is rolling without slipping. So let me give you one more question. One more question I want to give you because you have not still solved by yourself question. Angular model. Achha. See, try solving this. The question that I'm about to give you was asked in 2025 JEE Main. I'm sure you will be able to do it. It's not that difficult. Right. What answer? Yes, do it. If you want anything, ask me. If you do not remember any formula, you can ask me. Solid is for solid sphere. Achha, because it is solid sphere, let me tell you. For solid sphere, the moment of inertia is 2 by 5 mr square. Oh, this is tough for you. It looks tough, but trust me, it is easy. It's very easy. because when you read this line na, you will feel it is very tough. This line. But this line has actually no relation with the solving of problem.
So they have given it only to scare the students.
Yes. Yes, exactly. They have given this to only to scare you.
But I'm not getting the idea.
Not getting it.
So let's wait for others.
See how it will be solved now. Solid sphere with uniform density and radius r is rotating initially with constant angular velocity omega. It's rotating with some angular momentum. Okay. After some time, it starts losing mass means we are only concerned that it has lost mass. The angular velocity of sphere also they are asking when its radius become r by 2, value of x. So we'll directly apply conservation of angular momentum because there is no external torque involved. Everything which is done is internally. So I1 into omega 1 is equal to I2 into omega 2. Initial moment of inertia is 2 by 5 mr square because it was complete into omega 1. Now finally, see how it lost the mass, it's not necessary. That's why I said this line is not important at all. Finally, its radius has become r by 2. It has not changed its shape. It's still solid sphere. So its moment of inertia will be 2 by 5 into what? Now its mass will also change. m1 into r by 2 whole square. This is the part where most of the students do the mistake. Because to find the mass, you have to apply the density. You have to find out its density, volume density. Initially, its mass was m. 4 by 3 pi r cube divided by its volume will give you the mass per unit volume. Now, finally, when it has not changed its shape, but its radius has become r by 2, what its mass will be m1, it will be rho into its new volume, 4 by 3 pi into r by 2 whole cube. This is the tricky part. If you are able to identify this, this question will be solved easily. 4 by 3 pi into r cube by 8. It means what? The mass, new mass has become m by 8. Now easily we can apply it. 2 by 5. 2 by 5 will cancel. M r square into omega 1 will be equal to m by 8.
16 आ रहा है
हाँ तो सॉल्व कर ही लोगे नहीं 32 आ रहा है
32
हाँ
अच्छा इंटू 2 नहीं करना एक
हाँ
मैं क्या गलती हो गई मैंने 2 को ऐसे ही कैंसिल कर दिया
मेरा 32 आ रहा है इसका हाँ इसका 32 है ठीक है
32 है ना अरे मैंने
हाँ
2 को गलती से कैंसिल आउट कर दिया
अभी मेरे साथ पता है क्या हुआ था मुझे लगा कि तुमने बोला था ना 16 तो मैं दिमाग में क्या है कि अरे मेरा 32 क्यों आ रहा है आंसर 16 है फिर
अरे मैंने अपना आंसर चेक किया था तब मेरा 16 क्यों आ रहा है
32 is the answer actually. See, how was it? Easy or difficult? See, you cannot say this is new to you, this mass density, because in when I was showing you about center of mass, center of mass of the cavity, those questions I was showing you, I actually told you how to find out the mass density and how to find out the mass of any portion that you require using this mass density concept. Okay, and this density and finding out the mass actually we have used many times when we were trying to integrate, we were trying to take elements in center of mass, also for finding out the movement of inertia of uniform bodies. There, we should have done it. Okay, now understood everyone? Not a difficult thing.
Yes.
Okay, let's move on to the next concept. The next concept is rolling without slipping. Rolling without slipping is actually a concept which comes under translation plus rotation. Now see, in this, I'll explain, you know very well about translation part because the kinematic, you have studied it very well. But you do not know much about the rotation. Basic, you know. It comes under translation plus rotation. Achha, one thing I forgot to tell you. Sometimes, in moment of inertia, they give you the term. One term is there, radius of gyration. What is this term?
Radius of gyration.
Gyration?
That is something k into I no mk square, right?
Yes.
No, I by m root.
No. Same thing. You are telling same things. See, radius of gyration is I. Whatever momentum. See, you have different for every body. You have different kinds of body. You have different kind of moment of inertia. Like we were studying this one now. This solid sphere about its center of mass. The moment of inertia was 2 by 5 mr square. Now, when we talk about radius of gyration, whatever moment of inertia you are trying to find, you just equate that moment of inertia with m into k square. Means, what's the concept? Whatever the body is, you are treating that particular body as a point mass. What? How? Suppose you have a sphere here, solid sphere. It's solid one. Mass is uniformly distributed and every mass is at different distance, but we know its moment of inertia is 2 by 5 mr square. But what we are doing in the radius of gyration concept, we are treating this body, there is a point mass of mass equal to mass of the solid sphere, and it is present at a distance of k units from it. So that the moment of inertia of this solid body, which is 2 by 5 mr square, is actually equated with m into k square. Understood? Now, the value of k that we get, which is r root 2 by 5, it is different for different bodies. This is known as the radius of gyration. Why I am telling you this? Because you may be thinking, sir, it is an easy concept. Why we are knowing this? Because it does not have any effect on calculation. True, no effect on calculation. But sometimes in the question, they will specifically ask to calculate radius of gyration. And sometimes for a body, they'll not give the moment of inertia. They will give the radius of gyration. On the basis of that, you have to find out the moment of inertia. You have to get its moment of inertia in calculation. Okay, understood the concept? Whatever the body has the moment of inertia about any axis, about that particular axis, we treat the whole body as a point mass with mass equal to the original body situated at a distance of k unit from the axis. Then we find out the value of k. Okay, it's just a theoretical concept. Okay, easy. Now coming for rolling without slipping. It's translation plus rotation motion combined. See, where we see this rolling without slipping, actually many places in our daily life. You move in car na, or if you don't think anyone will be driving bike, motorcycle, but you may be driving bicycle. The motion of the wheel is actually translation plus rotation. Because if you see anywhere, at every point, this will have some velocity. It will be moving ahead. And at the same time, it's rolling also. It's rotating also with some angular velocity. Okay. Now to analyze its motion, since it is doing translation as well as rotation, what we will do, we will actually divide this motion of translation plus rotation into two parts. One is pure rotation, and the other is pure translation. This here you will understand everything. How the bikers make wheelie and all those things. Everything you will understand. I am trying to. I have divided this translation plus rotation motion into two different parts. We'll analyze them separately and then we will recombine them. Okay. First, take the case of translation. In the case of translation, if you see, let's have the complex part. Let's make it more complex. It is having the angular velocity omega at a particular instant. It also has an angular acceleration alpha. Similarly, this is moving with the velocity v, and at the same time it has an acceleration a also. Okay, like that. Now let's take the case of translation. Translation is this body is moving with velocity v. It's also moving with the acceleration a. Now, since this is a solid body, what is the meaning of solid body? Solid body is actually you are reading solid mechanics only. And there is a whole lot of chapter in mechanical engineering. If you study mechanical, I know you won't study mechanical. No one will. You will all go to computer science. See, this is a solid body, but there is a solid mechanics. The whole chapter on it. Solid body is what? The solid body is that body in which the distance between the 2 points always remains same. Means, in simple terms, if I say the solid body does not deform. It does not deform. If you try to compress it, it won't compress. If you try to stretch it, it won't stretch. Like that. This is a solid body. In a solid body, if this is a body, the center of mass is moving with the velocity v, moving with the acceleration a, every part every part of the body will be moving with the velocity v and acceleration a. Whatever you take, if you take the top point A, it will be moving with velocity v and a. If you take this corner point, it's moving with velocity v and a. The bottommost point, as we say, this C, the C point will also move with velocity v and acceleration a. This D point will also move with the velocity v and acceleration a. Means it's just doing the it's like a translation motion. Single body doing moving translation motion. If a forward point is moving with some velocity and acceleration, the backward point also moves with the same velocity and acceleration. Na? Top and bottom also like that. Clear? Okay ना everyone? क्या हो गया भैया, सब लोग चुप क्यों हो गए? अभी तो मैंने डिफिकल्टी स्टार्ट ही नहीं की है. दिस इज सिंपल वन. चुप हो गए. एवरीवन इज साइलेंट.
सर आ गया है सर.
समझ गए? See, now this is okay. Now see, in this translation, because this is moving with acceleration a, after time t, you can apply these equations. V is equal to u plus at. At any point, if you this is at time t equal to 0. If after time t, if you want to find out the velocity, it will be u plus at. Velocity will change like that. Okay. I should have given u here. Similarly, I should have given omega naught. And the kinetic energy, if you want to know, at any instant, it will be half into m into v square. At any instant, initial velocity was u. After any time t, velocity will be u plus at, and kinetic energy will be half mv square. Okay. Now coming to rotation part. In the rotation, it had at time t equal to 0, its angular velocity was omega naught. It's moving with omega alpha. Let's freeze this at particular instant omega. This part b, if the radius of this body is r, then can I say the body, this point B will have a tangential velocity like this? Pb is equal to r omega. Okay, na? Also, the point C will have backward velocity, which will be Vc is equal to r omega. Similarly, this D point will have top velocity in the top direction, r omega. This in the forward direction. Okay. Clear enough to here? If anyone has doubts, ask me. Similarly, if it is moving with the angular acceleration alpha, its acceleration will be, tangential acceleration will be r alpha. Its acceleration will be AC will be r alpha in this backward direction. Its acceleration AD will be equal to again r alpha in the top direction. AA will be equal to r alpha in the forward direction. Okay? Same direction. Clear enough to here? Now if you try to find out, since I have given this angular velocity omega at this particular point, what this omega will be? Omega is equal to initial velocity omega naught plus alpha into t, like that. Those things you can apply because you already know it. And if you try to find out the kinetic energy, so it will be half into I into omega square at that particular instant. Okay? Now you have actually analyzed the translation motion as well as the rotation motion separately. Now I want you to combine them. Okay. Now if I combine them, making this diagram, actually very simple. It's not
So
difficult.
will there be centripetal acceleration also?
Yes, centripetal acceleration will be there, but I have not shown it. For every mass at every point which is at a distance of r from it, there will be centripetal acceleration towards the center, v square by r. Okay.
Okay, sir.
But because the centripetal acceleration is always acting towards the center, I have not shown it. Now just combine them, both of them. If I say that top point, it will have the velocity what? V plus r omega. Similarly, the acceleration is a plus r alpha. Because after time t, it has the velocity v, na? Write v only here. Because it's not the initial case. I have freeze at a particular point, na? After time
You're
t.
slightly confused.
Huh?
Slightly getting confused for me.
Why? Where you're getting confused? Let's remove your confusion first. Where? See, this is pure rotation part that you have already learned. This is pure translation part.
So now you're trying to combine both. That's it.
At that point. Okay. See, when we are combining it, due to translation, the top point has the velocity v, and due to rotation, it has the velocity r omega. So I have combined them both, v plus r omega. Similarly, acceleration is a plus r alpha.
Okay.
Now coming to the point B, this point B will be having the velocity v in the forward direction and r omega in the bottom direction. So its velocity will be, net velocity will be in this direction, will be root over v square plus r omega whole square. Okay. Similarly, acceleration is in this direction, r alpha is in this direction. So the net acceleration also will be in this direction. Okay. This is just, I'm just trying to show you how to calculate the net one. Not needed. It has two accelerations, forward and the downward direction. Coming to the part D, it has the acceleration forward direction as well as velocity in the forward direction, and it has the acceleration r alpha in the top direction and r omega velocity in the top direction. Okay. Now coming to the bottommost point. Bottommost point has the velocity v in the forward direction and one more velocity r omega in the backward direction. Acceleration also a in the forward direction, r alpha also in the backward direction. Now I was talking about, this is okay, na? This thing, combining. I'm giving you time to analyze. Just see by yourself. Is it okay for everyone? I actually did not show you the acceleration of centripetal acceleration. I did not include it here. Okay. Okay, na everyone? Diva, okay?
Yes, sir.
Haripriya, okay?
Yes.
See, now I was talking about this part na, slipping. This slipping is actually related with the bottommost point. This bottom point. Can I say if this velocity v, if see, if the bottommost point is stationary, it won't slip. Because when a body slips, this point is there, it's present on the surface. If it is moving forward, it is slipping, or it is moving backward, it is slipping. Correct now? If it is not moving at all, it is stationary, it won't slip now. So the condition for no slipping is v minus r omega, means the bottommost point velocity becomes 0. And when this happens, v becomes equal to r omega. When v minus r omega is 0, v is equal to r omega. At that time, a minus r alpha will also be equal to 0. A will be equal to r alpha. These are the condition for no slipping. And actually, in the slipping, to prevent slipping, the friction plays a very good role. Friction actually creates alpha. Because of this alpha, the body gets the angular velocity, and due to this angular velocity, that r omega term comes, and which cancels out velocity v, forward velocity v, and that's why the condition of no slipping occurs. That's why we say friction is very important in our daily life. If friction is not there, everybody will slip. You see, this last part will be a bit confusing for you, that I just now told. You just tell me, do you understand, did you understand this part? V, condition for no slipping. V is equal to r omega, A is equal to r alpha. Shama?
Yes, understood.
Everyone? Haripriya, Radhika, Diva, Kanishka?
Yes.
Yes.
Now, actually, see, what I was telling you now, why friction is important. I'll give you an example. This is a body. This is a body. It was just, it's capable of rotating, but initially at time t equal to 0, it was only moving with a velocity v. Okay. Now, since it is only translating on the surface, it should slide, because it's sliding now. It's because it is moving forward only, it's not rotating. So the friction will act backward. You know what it is. Friction is mu into normal reaction, mu into mg. Because of this friction, what will happen? This friction will apply a torque about the center. What it will be? Torque will be mu into normal reaction friction force into R, which will be equal to I alpha, so that you'll get an alpha. In this direction. It did not have any angular velocity by now, but due to this friction, it has got an angular acceleration, and ultimately after time t, what will happen? Let's say initially it had velocity u. Now after time t, what will happen? Its angular velocity will become omega is equal to 0, because initially it has 0 angular velocity, plus alpha into t. And after time t, its velocity v will be u plus a into t. In this case, no velocity. Acceleration is not there because only friction is acting. So friction is acting, so there will be an acceleration. Acceleration will be what? Mu into normal reaction divided by its mass in the backward direction. So V will be what? U minus mu into normal reaction by m into t, because acceleration is backward direction. Okay. Now, after time t, what the situation became, this started rotating also, because it has got angular velocity omega. Its velocity has reduced a bit. Its velocity has become v, and there will be an instant. At this instant, when it is rotating as well as translating, v and this part r omega will come, and there will be an instant when v will become equal to r omega, so that this point will become stationary, stationary. At this point, the slipping will stop. It will roll without slipping. So how do you do the calculation? V u minus mu into normal reaction by m into t is equal to r into alpha t. You'll calculate the time. U is equal to r alpha plus mu into normal reaction by m into t. So the time you have actually calculated a time after which it will start to roll without slipping. R alpha plus mu into normal reaction by m. This is the time t. Understood? Actually, through this example, what I wanted to show, how the friction force is responsible for a body to roll without slipping. Initially, it was just sliding. You have just kept it. It was sliding, and because of this friction force, it started to roll, and it started to roll without slipping after some time, because this angular velocity omega came. Similarly, there is because time is not there. In the next class, I'll tell you that case when I'm just rotating a body continuously, and I just keep this rotating body on the surface, and then after some time it starts to translate. Why? Because of the friction force only. Because when a body, just let me tell you, when a body is just rotating like this, initially, when you keep it on the surface, this point is moving backward, the friction force will act forward. And because of this, it will start to move in the forward direction. And again, it was initially just doing the rotation motion. After some time, it will do the rotation plus translation. And because of this friction force, it will do rolling without slipping. So just review this concept after the class. And just if you have any doubt in the next class, you can ask me. Then we'll start to do the problems on this. Okay. Let's end it. Bye-bye.